Okay, this is the lesson that goes with worksheet 10. We're going to talk about something called the power rule. You use this to find the derivative. The derivative references the slope, or specifically rate of change. So if I have a function f of x equals x squared, the slope at 1, the line that's tangent, is going to be different than the slope at 2. And so the derivative allows me to find the slope at any point along this curve. And so how you do that, I'm going to do a generic, the generic form. This is like the rule. A times, now instead of a box, I'm going to use a pentagon. And it's to the power of the box, okay? So if I have some number times something to the power of something else, to do that, I'm going to take this box and I'm going to move it to the front. So you get box times A, and the pentagon stays. So all you do is take this, see, and you move it to the front. And then, now the new exponent becomes that box minus 1. So when I apply that to here, the number in front is a 1. That's my A is 1. My pentagon is the x, and the power, I'm just going to take this 2 and I move it to the front. 2 times x, and now this exponent is going to become 1 less. So the answer is going to be 2x. So if I want to know what the slope is, this is called the derivative. You put the little prime symbol there. The derivative of x squared is 2x. So if I want to know what the derivative is at 1, I plug 1 in. So this has a slope of 2. I want to know what the slope of at 2 is. This line right here, 2 times 2 is 4. So the slopes are different at all those different positions. Let me go through a couple of examples. I have 7 little examples for you. Let's say I have 3x to the 5th. Okay, all we're going to do is we're going to take this 5 and move it to the front. So this is going to be 5 times 3 x to the 5 minus 1. So the derivative, with the derivative, the exponent goes down by 1. Okay, so my answer is going to be 15x to the 4th. So with derivative, exponent, okay, derivative, exponent goes down by 1. So the reason I'm making a big deal is this begins with a D and this begins with a D. So derivative down. Okay. All right, let's try another example. How about something like 1/2 x to the 8th? Okay, we're going to apply the same thing. Put that 8 in the front times 1/2 x to the, this has become 8. So this became 8 minus 1, so we're going to get 4 times x to the 7th. 8 times 1/2 is 4, 8 minus 1 is 7. So I'm showing you the step that I'm doing and what I'm thinking in my head, but really as you get better at this, you can just go, oh, 8 times 1/2 is 4, and go straight to that spot right here. Let's try another one. What if we have something like this, 5x squared plus 6x minus 3? Okay, now this one, you treat each term inside this polynomial as a separate identity. Okay, so where I'm going to take this 2 and I'm going to pass it out here. This is going to be 2 times 5 times x, 2 minus 1 is 1. Okay, plus this is a 1, so 1 times 6 is 6x to the 0 minus, okay, so there's no x here. If there was, it'd be x to the power of 0. Okay, so 0, that's going to be 0 times 3 x to the 0 minus 1. So wait, just the number -3, just a constant. Anytime there is a constant, the derivative is always going to be 0. The derivative equals 0, because 0 times anything is just 0, so that's just going to cancel out. So this answer would be 10x plus, and then x to the 0, x to the power of 0 is 1. 1 times 6 is 6. So this would just be the answer. Okay, so if I did it here, I'd go 2 times 5 is 10. X, in my head, I can go 2 minus 1 is 1. 1 times 6, then that's just going to be 6. We're done. Okay, let's do another example. How about something like this? X plus 3 squared. Now, not until the next video are you going to know a shortcut for this. But for now, on this worksheet, you need to factor this, or like multiply this all out. We all know that this is really x plus 3 times x plus 3. And when you multiply that out, you get x squared plus 6x plus 9. Now this is very much like the problem we did right above it. So we're just going to take the derivative. I'm going to take this 2, I'm going to put it in front. So I'm going to get 2x, and then 2 minus 1 is 1. And then, oh, I still have a 6 there. And now this is a constant, and the derivative of a constant is 0. So I'm just going to stop right there. That's it. Okay. Try another example. How about x to the third times 12 minus x? Well, again, I have two things multiplied together, so I don't know how to do that yet. So I'm going to just do the distributive property. We're going to get 12x to the third minus x to the fourth. Okay, x to the fourth. So now just do the power rule. Take this exponent and multiply it by the 12. 3 times 12 equals 36. X to the 3 minus 1. 3 minus 1 minus, move this 4 to the front, 4x to the 4 minus 1. So my final answer is going to be 36x squared minus 4x to the third. All right, 6. Now what if we have something like this, radical x? How do we deal with that? Well, hopefully you remember that anything to this radical, it can be written as x to the power of 1/2. Once I write it that way, it's super easy. I just take this 1/2 and I move it in front, and then it's going to be 1/2 minus 1. Well, 1/2 minus 1 is 1/2 negative 1/2. 1/2 x to the negative 1/2. So now how can I write this portion of that? How can I write that? Well, if I move that to the bottom, it becomes x to the positive 1/2, and then that can be written as 1 over 2 times radical x. So this is a better way of looking at that answer. And the same thing is, what if I have, squeeze this one more problem on here, number 7. What if I have the 8th root of x to the 5th? So this is the root, and I asked one of my non-math friends, like, hey, if you were to write this as a fraction, where do you think this would go? Surprisingly, she came up with a really good idea. She says, well, I know roots grow in the ground, so I would put it on the bottom. So just write it as x to the 5/8. So you're going to take this, and it goes to the front. 5/8 x to the, now what is 5/8 minus 1? But I'm going to write 1 as 8/8. Okay, 5/8 minus 1 is 8/8. And so we're going to get 5/8 x to the negative 3/8, and I can write that as 5/8. I want to squeeze it on this piece of paper. 5/8 the square root of, that's on the bottom. Okay, this is really bad penmanship here. Now my root is 8 and my inside is 3. Okay, I did it in a different color so we could kind of tell the difference. Okay, I fit it on the page. That's the end of those notes. Have fun. It's an easy section.